All right. Hello, everybody. This is Eric, your adjunct instructor, and today I'm going to be going over errors in Python. This is a little series I call MiniLec 1. This is the first one in that series, and it's sort of like a mini lecture. That's for our online component. We're not going to have these every week, but I thought that this week had enough material to cover in its own little lecture. So today we're going to talk about errors in Python. Errors are a really important concept in programming because you're going to make mistakes as you code, no matter how good you get. There are lots of different types of mistakes, and they each have different causes and fixes. Going over all of the different types of errors and their solutions will definitely help you be a better programmer to avoid these mistakes in the future and to correct them quickly. So, it should actually be pretty interesting. There's a lot of different uniqueness that goes on in coding that doesn't really happen in some other areas of life. So enjoy it. All right, so first we're going to go over the different categories of errors. And now this is the more conceptual side of this lecture. And there are three categories of errors: syntax errors, runtime errors, and logic errors. Let's take a first look at syntax errors. So syntax errors occur when Python code is just not valid grammatically or structurally. So this is something that you might compare to the red underline in Microsoft Word, or perhaps a file on your computer that's been corrupted so that it won't even open. In this case, your program won't even start. Python will throw an error and complain. So you will see an explicit error message for this type of error. I'll show you this in a little bit. Another conceptual error type is a runtime error. This occurs when an illegal operation happens while the program is still running. Basically, you're asking Python to do something that it does not know how to do or just doesn't make any sense. For example, dividing by zero. That is a classic example. You'll see it on your calculators. Actually, one of the few errors that you'll see on your calculator is if you try to divide something by zero. That's this exact concept, a runtime error. It may happen at any point while your program is running, and it will cause an explicit error message, just like syntax errors. These are a little harder to find. If you have a large program with lots of different branching paths, say a user only goes down one path and not another, you may or may not see a specific instance of a runtime error. Lastly, the third type is a logic error, and this is even a little bit trickier to find. This occurs when your code doesn't do what you intended to do, but it doesn't cause an explicit error message. When might that happen? I'll show you that in a little bit. This may happen at any point while your program is running, just like a runtime error. Now, even though it doesn't create an explicit error message, it may cause a runtime error in the future. All right, let's look at Python's error types. And as we go through this, I'll do some examples in Jupyter. So, first of all, we've got our syntax error. Well, didn't you already mention syntax error, you may say? And yes, we did. That was the first example in the categories. But Python has an explicit error type called syntax error. Syntax errors have the same definition as a category I mentioned before, so it's something in the grammatical structure of your Python code is invalid in a way that the Python interpreter just doesn't know how to run your code. You'll see the failure before the code even runs. A common example may be an invalid variable name, forgetting a parentheses, or improper indentation. So let's take a look at a syntax error here. All right, so we're gonna pull up the terminal. And remember, for those on Mac OS, Windows computers, you'll be pulling up PowerShell. And we can type Jupyter Lab and press enter. You'll wait a second and then you'll see Jupyter open up. And again, mine opens on my secondary screen, so I drag it over. And what we'll do is just create a new notebook right here. So we're going over syntax errors. Let's create some here. So we've done work on variables. Variables can produce syntax errors if you use an invalid name. So let's say we want a number of students, right? We're going to track student data. What if we called our variable one student? So instead of student one, we say one student. I don't know, doesn't make a lot of sense, but it's something conceivably someone could do. And let's say their name is John. Now, what happens if we run this code? All right, here we go. Syntax error, invalid decimal literal. So you're seeing this syntax error because we have a 1 here in front of the variable name. And again, that's not permitted. So let's look at the error message that comes up when we get this error. This is generally called a traceback, this first section right here. The tracebacks helps us to find where this error occurred in our code. So we see cell in 1, line 2. All right, this is cell 1 right here, and line 2, 1, 2. All right, excellent. We also see the line repeated right here, and we see this little caret here pointing to where exactly the error happened. So this section, the traceback, helps us find where the error is. We'll then get this right here, which is the error type. As mentioned, Python has a lot of different types of errors built in. Those built-in errors have specific internal code which helps to narrow down for the user what happened and what went wrong. Specifically here, the code for this syntax error is spitting out this just very short description. So, all right, we have the traceback up here, we've got the error type here, and then we've got a description that will come with our errors. Let's take a look at what it says. It says invalid decimal literal. All right, I'm gonna zoom in just a little bit here. Invalid decimal literal. What does that mean? Well, hopefully you all remember literals, which we talked about before. A literal is just a value without a variable. So 1 is a literal because it's just a value. We can also say hello. This is also a literal. This is number 1 is an integer literal, and then hello here is a string literal. All right, so I'll delete that here. It's saying invalid decimal literal. So what's happening? It's taking a look at the 1 here, and because the only things that start with 1s are decimal literals, whether integers or floating points, it's saying, okay, well, we're starting a number here. But then after that, it sees student. So it doesn't know how to interpret this. I mean, what is student? I don't know. It's one student. One student, it's a string, a number. Python doesn't know what it is the point, right? So if we were to actually fix this variable name and run this again, you're not going to get any errors. Another common error type is if you forget to close a parentheses or perhaps forget to close quotation marks. So what happens if we delete this quote here? All right, let's run this. Syntax error, unterminated string literal, detected at line 2. Excellent. That's a very helpful error message. It tells you where the message is. It points to the first, let's say, double quotes here, and it tells us that the string literal was not terminated. So Python doesn't know. Let's say we write some code here, print 1 plus 1. Python, without closing this literal here, it wouldn't know whether this print statement is part of this or not. Well, in this case, because it's empty, it's on a single line, we actually would generally know that it's not. But the point is that Python doesn't exactly know where the end is. This would be very much more clear here if we use the triple quotes, which allows you to do multi-line strings. You'll see that this here is highlighted in the same color as John. We didn't close John here, so it thinks that this print statement is actually part of this student variable. Excellent. You're also going to see, as I mentioned, unterminated parentheses as well. So if you said print and I think this will become a running joke, how terrible I am at typing, we're going to see incomplete input, right? So it doesn't know whether you've typed everything that you need. It doesn't know what's inside the parentheses and what would maybe be outside of the parentheses. Excellent. So let's go back to our PowerPoint here. We've discussed a bit, but I've showed you a bit of the Python error output here. We've seen that there's 3 sections. There's the traceback, there's the error type, and then there's the description. So let's go back to our different types of errors. Syntax error. You've seen what it is. It's basically the language you've used is broken. It's not complete. You've made a mistake. It would be highlighted red in Microsoft Word. So how do we fix that? Well, we can use the syntax error message that you've seen to help identify where the error is. Oftentimes there's a little caret pointing exactly to where it is. And then you can just check the Python rules related to that code type. If you need to know the variable name rules, you can search that up. They're pretty easy to find. The same thing with how to define a function, how to define an iterable, or how to define, say, a conditional. All right. So we've gone over syntax error. Let's move on to name error. Now, name error is a little different than syntax error because it is a runtime error. Syntax error didn't even run the code, all right, before it threw this error right here. Let's take a look and prove that. Let's say print hello, and let's do this properly. Let's close it properly, and let's run this code. All right, we actually don't see hello printed. That means it isn't even running the code at all. Runtime errors will allow you to start the code, but will fail partway through. And you'll see a quote here from the Python documentation. They're raised when a variable is not found, okay? That's pretty self-explanatory, hopefully, but there's actually a few causes that you might not think about. So common causes are that you've misspelled a variable or function name, or you didn't execute the code to define the variable or function before using this variable or function. Let's delete this here and take a look. All right, so let's have one cell here where I write my car equals Ford Fusion. And let's create another cell here where we say print my car. So what happens if we don't run this, but we run this one? All right, excellent. We get a name error. We have our trace back here pointing to where it is, and we have the error type as name error, and it says name my car is not defined. This is because Python doesn't know what my car is. It could be anything, and Python's not going to guess if it doesn't already know. If we then define the variable right here, and then run this code again, the error will be gone. Excellent. Another common cause is if you misspell the variable or function name. All right, so what if we did print my car? All right, it doesn't know what that is either. We have different capitalization here on this variable than we do when we defined it. So a common fix, check spelling and capitalization. Yes, capitalization does matter. And then another fix is make sure you run the cell defining a variable or function before you use it. This applies specifically to Jupyter because it has the concept of cells. But in standard Python files, you would want to actually make sure perhaps that you didn't accidentally put the use physically before in the same cell, or sorry, in the same file. So if we do, for example, this here, let's put them in the same cell to emulate as if they were in the same file. And let's delete this here, and you see the same error because we're printing it and then defining it. This is actually a lot more common if you're using if statements. So you say, I found this to be like if user, let's say, let's just do if true. All right, my car equals Ford Fusion. And then we have else. And then we just do, let's just say, user has car equals false. Okay, so we have here that a conditional where if something is true, we set my car to Ford Fusion, else we just set a variable that user has a car to false. So then if we do print my car, this will work if this is true, if this condition runs, but it won't work if this one doesn't. So that's really the most common, in my experience, situation where you're going to encounter that in terms of defining things before they're used. Excellent. So we've gone over the name error. It's raised when a variable is not found, and it's a type of runtime error. All right, we're going to go over another type of runtime error here, the type error. A type error is raised when an operation or function is applied to an object, including variables of inappropriate types. That's directly from the Python documentation. A common cause is using two incompatible data types with an operator. As you hopefully remember, operators work with specific types of data. And as an example, the plus operator with two integers will work to add those two integers, whereas with two strings, it will work to push them together, so concatenate them. If you try to use a plus operator and any operator with some two types of data that are incompatible with each other, or perhaps just a data type that's incompatible, you will get a type error. Let's look at an example of that. And let's say 1 plus string 1. All right, running that, we get a type error. Here's our sort of three-part error code again to trace back, telling us where it is. Here is the error type, and this is the error message. Again, it uses very technical language, but let's parse through it right here. Plus is the operator. On each side of the plus statement, or any operator, there's going to be something called an operand, sort of like, let's say, leasor and leasee, right? It's kind of like the two sides of one coin. So we have the operand. The two operands you're using are right here, integer and string, and it's saying this is not supported. You can't use an integer and a string together with the plus operator. Excellent. So let's go back here and take a look at another common cause, which is using the wrong data type as a function argument. I don't believe by this time, I'm not completely sure, but I don't believe we will have yet covered functions. But basically a function like print, say print. If you put the wrong data type in here, an error would occur. I think the print statement is actually flexible enough to take any data type, but it just to visually show you what something like that might look like. What are some fixes? Well, one is we can use good variable names. What do I mean by that? Well, what if we had x equals Ford Fusion, and then we had y equals 16 for gallons of gas in gas tank, and then we had z equals 27, and then this is miles per gallon, right? So we have this here, and let's say sometime later we're gonna scroll down here, and then we say, okay, well we have x, y, and z, right? Okay, and then we're like, well, we want to calculate how many miles it can go on a gas tank of gas. So let's say we do print. Oh my gosh, print. Let's say x times z, right? Okay, so print the gallons of gas times the miles per gallon. That should get it. Well, we have to run this here first, of course, to define what we need, but then we can run this. Ooh, that's not what we're looking for. Actually, this isn't the example I was looking for either, but it shows at least the concept that using variables here, wrong variable names, can oftentimes cause us to mix types where we get unexpected behavior. All right. So what are some fixes? Again, using good variable names. And then the second one is cast variables to the appropriate type. All right. So what does that look like? Well, we'll go back up to this line of code here, and what we're going to say print. We're going to print Ford Fusion gets 27 miles per gallon, but we're going to use the variables. All right. So x is Ford Fusion, and then we're going to say plus space gets plus, and then 27 is variable z, and plus, and then miles per gallon. Excellent. What happens when we run this? Bam, we get a type error. Why is that? Another operand here, right? We already talked about the fact that the plus operator can't work between a string and an integer. So what do? Well, I said before, casting a variable. So casting a variable means that you turn one variable type into another. So the value of z here is 27. Let's highlight it. Well, I'll just put parentheses around it here. Now I can use a special function called str. And in Python, the str function will convert some type of other variable data type into a string. It works on a lot of different types, but let's run this now. Bam, Ford Fusion gets 27 miles per gallon. So a fix is casting. And how do we actually tell, by the way? Let's say we have some code and we actually don't know what data type this is. In this case, hopefully we know it's an integer, but we can actually check the type of a variable by having type, just the function called type, and then you put in parentheses what you want to check the type of. Let's run this right here, and you say class integer, right? Int. Excellent. So you can check what type it is using the type function, and then you can cast it to the proper variable. Now, casting doesn't always work. Now we can cast, let's say, a string 11, right? We can cast this into an integer. And this isn't the usual code editor I'm at, so that doesn't work. Is putting the parentheses around that. So let's turn the string 11 into an integer here. All right, and we get 11. Excellent. But what if we put A in here? Or Z? Well, we're going to get a value error. Invalid literal for integer with base 10, 11Z. So that you're going to see that as well. You just have to make sure the string actually contains something that Python knows how to translate into that other option. Excellent. So we've gone over the type error. We've gone over the common causes and fixes and casting from one variable type to another. Now let's talk about logic errors, and we've actually just seen one. Yes, this is not actually an explicit error defined by Python. Your logic error will actually work just fine. It's a conceptual error type. And it occurs when you code the program logic incorrectly. Some analogies might be accidentally using the wrong word in a text. Well, the text is still valid. It's not going to break when you send the text. It's not going to cause some sort of error, like if you for somehow you were able to shove some sort of non-existent character into there and your iPhone didn't understand how to process it. No, your text is valid. And also, the word might be completely valid too. But you've used the wrong word, and so the person who gets the text doesn't understand it. Another analogy might be a little bit bigger, is using an incorrect fact in an essay. Say you're writing an essay, and this essay goes through different facts about computer processors, right? How about how they're made? Somebody takes a look at your essay and says, you know what, I want to replicate the information in this. I'm going to use this information to build a computer processor, right? So they study your essay and they go to work building the computer processor, and it doesn't work. Why is that? Because you've included an incorrect fact that is atrocious enough to actually make the whole process fail. So that is an example of a logic error. Let's take a look back here. All right, so we've had our bad variable names. Ford Fusion gets 16-gallon gas tank and gets 27 miles per gallon. All right, and we've multiplied x times z. Well, why do we get this here? Well, x here is the car name, Ford Fusion, and the z here is 27. So we're actually multiplying the string times 27. So we're getting the string 27 times. That's very obviously not what we were trying to do. But here, it works. There's no error. But it's just some weird output that you don't expect. You'll encounter plenty of these. I still do after years of programming. And here's the sources. I hope you enjoyed this video about Python error types, and hope you found it informative. Thank you all very much, and see you next time.